Okay, so one tool that I'm using a lot is NotebookLM. If you don't know, so that's one way that I'll teach you how at least I'm using it. Basically, I'm using it to research a subject and then condense it on either a podcast or a slide. So now I just came across the idea of a glitch token and the unspeakable token. And honestly, I don't know what this is, so I'll research it. In my experience, the Google model was the best for deep research and finding sources on the internet. And honestly, it would make sense since they have the database of Google to go for it. So I'll leave it running and I'll give you an idea of what it is afterward. Okay, so once it's discovered, you just need to click import. It will fetch the list of every website, so you can also check it. arXiv is a real paper from university and people in the field, so I tend to trust them more. But like, as you can see, it's fetching YouTube as well. It has really a bunch of different sources unless it's blocked. So will need to wait until he fetch everything. So the medium is blocking the AI from crawling it, so you can't get it. You can ask question here, but what I tend to do is I do a slide deck, and if I know I will go in my car or I like do something else, you can generate yourself a podcast. So like an audio overview, but I can show you all the detail if you want. So it's an explainer video that I want. Auto select, that's going to be fine. So with all the source that he just fetched from the internet is going to generate me slides, an audio overview, and an explainer video overview. So I'll come back once it's done. Okay, so it finished generating. It took about 20 minutes. What I usually do is check the PowerPoint. So usually it's super good, and then we can understand. So it basically explain the concept with images. It gives you the term. We can ask question around it as well. It means the AI is probability. I'm learning as we speak. I don't even know what is it. But yeah, it's mainly to give you an example. I'll read it offline. But it generates a good PowerPoint and explain a bunch of concepts related to it. You can also ask question here. So can you give it to me in one paragraph what a glitch token is? And it will check the source, everything is generated. Now the video, I don't usually do the video, so maybe it will be interesting to check. I'm not sure it's a good idea to just play it all the way, but yeah, it's the way to put it full screen. Yep.
Welcome to this explainer. I am so thrilled you're here with us today because we are going to do something absolutely incredible. We're essentially going to treat these closed-off, multi-billion-dollar AI models like a digital forensics crime scene. So if you're someone who loves a good mystery and really wants to understand how the foundational technology of our era actually works beneath the hood, well, you are definitely in the right place. Let's get right into it. Here's the core question, the hook for our whole investigation today. Can a single bizarre word reveal a tech giant's biggest secrets? I mean, think about it. These AI models are fiercely guarded by the companies that make them. Their training data, the underlying architecture, the specific fine-tuning processes, they're all locked away behind strict API walls. But what if these models are accidentally leaking their own structural secrets and their exact training recipes? Okay, let's dive into our very first massive clue. It's a phrase, and it's a weird one, solid gold magic harp. Yeah, you heard me right. Researchers were digging through the mathematical embedding spaces of models like GPT-J and GPT-3, and they found this completely bizarre, nonsensical phrase flowing near the very center of the model's vocabulary. And here's the crazy part. When they actually fed the word solid gold magic harp into these GPT models, the AI completely broke down. It would evade the prompt or just start acting incredibly strangely. It was literally like giving the AI a digital allergy. So that brings us to section 1, glitch tokens and AI ancestry, and how we can actually use these quirks to trace the lineage of models. To really grasp what's happening here, we need to define what we're looking at. These are what researchers call glitch tokens. Basically, they are undertrained or entirely untrained tokens that the models fundamentally struggle to even repeat. But why does this happen? Well, it turns out these specific tokens existed in the older dictionaries or tokenizers that break down text for the AI. But those specific words were almost completely absent from the newer, highly curated training data of models like GPT-3. Because the model never actually practiced how to speak them in context during its training, it just panics and hallucinates these structured anomalies whenever it sees them. Now look at this. This is the smoking gun data compiled by researchers over on Less Wrong, and it reveals a fascinating correlation. They realize, hey, if these glitch tokens cause a model to act weirdly, maybe models trained from the exact same starting point will act weirdly in the exact same way. And they were right. Look at the highly polished instruct model text EDA01. It predicts the token RE with a massive 24.43% probability. Right below it, its raw base model ADA scores it at about 0.29%. Now that might sound low, but if you compare it to completely unrelated base models like Babbage or Curie, they score it exponentially lower. This statistical correlation proves without a doubt that the polished instruct model shares an exact, bizarre output fingerprint with its original raw base model. This phenomenon perfectly demonstrates what researchers call fingerprint bifurcation. It's like a genetic trait being passed down. When you feed our original glitch token, solid gold magic harp, to the Power 4 base model code DaVinci 002, it reliably outputs one of two exact words, distribute or disperse, every single time. And sure enough, when you test its highly polished descendants like text DaVinci 002 or even ChatGPT, they inherit this exact same quirk. They fall into one of those two specific attractors. The glitch token essentially exposes the AI's hidden family tree.
Which leads us perfectly into section 2, leaking the training data. There's something called data mixture inference.
So as it turns out, tokenizers don't just reveal ancestry, they can actually leak the exact recipes of the data they were trained on. How on earth is this possible? It all comes down to the underlying mechanics of something called byte pair encoding, or BPE. BPE works by taking the most frequent symbols in a dataset and clumping them together to create predefined vocabularies. The whole point is to speed up processing, right? The fewer tokens an AI has to read, the faster it can think. But here's the massive vulnerability. Because BPE purely prioritizes frequency, any weird anomalies in the tokenizer's vocabulary directly expose the specific datasets, programming languages, or domains that were heavily mixed into the model's training. It inadvertently turns the tokenizer into a reverse engineering tool for forensic researchers. Let's look at how this plays out in the wild, in section 3, tokenizer bias and hallucinations, and the real-world consequences. Consider the number 199,997. That is a massive number, and it's the exact number of tokens predefined in GPT-4o's vocabulary library. To speed up inference and make the model faster and cheaper to run, the developers massively increased the size of its vocabulary compared to earlier versions. But, unfortunately, taking this shortcut and cramming so many complex, long tokens into the library introduced some really severe new vulnerabilities. And this vulnerability creates absolutely disastrous translations. Take a look at this. On the left, we have a totally benign promotional message in Chinese that translates roughly to, WeChat official account, win the lottery every day. But when you run it through GPT-4o, the tokenizer completely warps it. It hallucinates a severe financial crime, interpreting the text on the right as WeChat money laundering or cash flow manipulation. You have to ask yourself, how does an advanced AI make a mistake that incredibly severe?
Well, it comes down to tokenizer bias. Because mainland China's internet ecosystem is heavily siloed by large corporations that block web crawlers, AI tokenizers have to heavily rely on open web Chinese data found outside the mainland. And statistically speaking, this open web data has a massive overrepresentation of adult and gambling content. So that BPE algorithm we talked about earlier, it dutifully merged these frequent, albeit highly inappropriate terms, into long, predefined tokens. It literally polluted the tokenizer's foundation with this highly unusual, contextually biased vocabulary that the main model barely even understands.
And the performance drop-off is highly measurable when researchers analyze token retention accuracy, which is basically just how well the model can recall and use a given token in a sentence. The results are wild. For these long, complex Chinese tokens, the older GPT-4 retains them successfully about 80.72% of the time, but the newer, supposedly faster GPT-4o, it plummets to just 45.18%. GPT-4o actually struggles immensely with these long, corrupted tokens compared to its older predecessor. It's solid proof that a larger vocabulary doesn't automatically mean better comprehension if the underlying data is skewed.
All right, so how do we fix this mess? Section 4, fixing the broken tokens and mitigation strategies.
Researchers have actually identified a really effective, structured approach to repair these biased foundations. Step 1, obviously, is actively identifying these problematic glitch tokens. But step 2 is where it gets fascinating. They bypass the AI's broken tokenizer entirely. By using professional external segmentation tools, like one called Jiba, they manually break down these long, polluted tokens into smaller, common words before ever feeding them to the AI. Doing this completely restored GPT-4o's ability to understand the text. And finally, step 3 is the crucial long-term fix, strictly filtering low-quality, biased data out of the training corpora before the tokenizer is even built in the first place.
As we wrap up this investigation, I really want you to consider this incredible insight from researcher JDP. It's on the flaws where the underlying machinery is revealed. That hits the nail right on the head, doesn't it? AI mistakes are not just random noise. When an AI hallucinates or breaks on a glitch token, it's an out-of-distribution input revealing the true, hidden cognitive machinery of the model itself. These flaws are, quite literally, the ultimate digital fingerprints. And that leaves us with a lingering, absolutely vital question to think about. If tokenizers act as the structural DNA of AI, carrying the inherited traits, the flaws, and the biases of their ancestors and their training data, what other hidden biases are quietly baked into the fundamental building blocks of the digital tools we rely on every single day? It's something we all need to be asking as we build the future.
So yeah, that's just an example of the video that was generated. We didn't see the statistic that he was talking about in the video, but other than that, it's not bad. So let's check the...
Welcome to the Deep Dive. I'm your host, and as always, I'm joined by our resident AI expert to unpack some of the most fascinating tech research out there.
Hey everyone, really excited to be here for this one.
Yeah, this topic is, it's a bit of a mind bender because, you know, when you sit down and type a prompt into an AI...
the whole clip as well, but yeah, if we jump ahead...
King and queen are close together, apple and banana are close together.
Makes sense.
But the mathematical center of that map is essentially a feature...
And you can also call in. That's something that's really amazing. Host to join.
Oh, hey there, how can we help?
Hey, long-time listener. Can you give me a one paragraph sample of basically what you're talking about?
Oh yeah? Huh?
Give me a one paragraph sample of what you're talking about.
You've got it, and honestly, seeing this in action is the best way to understand the madness.
Okay, let's unpack a real-world example involving a glitch token called the nitrome from a recent study.
Imagine you ask a model, what do we know about the game Studio Nitro?
Usually the model handles this perfectly because it breaks the word down into
So yeah, you can ask question, and then that's one of the way that I learn complex topic. And it's honestly useful. I use it nearly every week. So if you want more tips on how I use apps, let me know.